Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Cyclohexene has one C is equal to C double bond. Cleavage of this double bond opens the ring, and if both carbons of the double bond are converted to aldehyde or carboxylic acid groups, subsequent reduction gives the terminal diol HO CH2 6O. Option A. O3Zn reductive workup performs ozonolysis giving a dialdehyde OHC-CH2 4-CHO hexanediol. Lyl4 then reduces both aldehyde groups to primary alcohols, giving HO CH2 6O. This works. Option B. O3H2O2 oxidative workup performs ozonolysis giving a dicarboxylic acid HOOC-CH2 4-CHO hexanedioic acid adipic acid. Lyl4 then reduces both carboxylic acid groups to primary alcohols, giving HO CH2 6O. This works. Option C. Cold dilute KMNO4 performs SYN-dehydroxylthione of the double bond, giving cyclohexane 1,2 diol, a vicinal diol. IChO4, periodic acid, then cleaves the vicinal diol oxidatively, breaking the C to C bond and giving OHC-CH2 4-CHO hexanediol, the same dialdehyde as in option A. Lyl4 then reduces both aldehydes to give HO CH2 6O. This works. Since all three methods independently achieve the conversion of cyclohexene to HO CH2 6O, the answer is D, all of these. Therefore, the correct answer is D. Therefore, the correct answer is option D.